So in this topic, we'll see about inter-process communication. Inter-process communication, again, like as name suggests, it's an communication happening between two processes, between two parallelly running threads. So process here word does not actually mean like or only means the process. It is even the communication between two threads or the two tasks running. So we'll see ki what it means and what are the different techniques of this and why it is required. So why we need a process synchronization and what is the communication? So the different processes running like can be of two types. Either they can be independent processes or the cooperative processes. Independent process we mean like when the multiple processes are running, when the multiple tasks are running, and one does not affect the execution of the other, then we call it as an independent. And when the output of one affects the other, or the execution of one task affects the execution of another, then it is called as an cooperative process. So in that situation, we basically need the synchronization between two processes. The simple example, let's say I have two tasks running. One task is displaying some data onto LCD, and one task is displaying some data onto the UART. They are connected to different ports of the microcontroller, and they are running with their functionality. So in this case, the task which is displaying data onto UART and the task which is displaying data on LCD are totally independent, and one does not affect the execution of other. Whereas if we consider a case like one task is reading a data from some sensor and another task is displaying that data onto the LCD. So in this situation, unless and until I get some data from sensor, it cannot be displayed. So the execution of my second task is totally dependent on the execution of my first task. So here these two are the cooperative processes, and here we basically need a synchronization. So the property of threads, the processes they run parallelly as and when you create the execution starts. So we basically need the synchronization in this scenario, in such scenarios basically. Uh, so the another important concept is like the critical section of the code. Like when there are cooperative processes running, let's take the same example. One task is reading a data from sensor and another one is displaying that onto the LCD. So the task which is running on running with some sensor, and so after the sensor reading, the sensor measurements are being stored into the some global variable, and the another task is using that global variable to display the value onto LCD. So here that global variable is shared between two. So that is so that part of the code, that variable is comes under the critical section of the code, because only that variable will be used by both the task, and unless and until like first updates, the second cannot read that. So it is the critical section of the code. So what is the inter-process communication? So when the cooperative processes are running, uh, it is not that every time the processes will be independently running. However, cooperative processes are being designed such that to increase the computational speed and convenience of the user. I so and to have a synchronization between them, To make them synchronize, we basically use IPC tools. So inter-process communication is a mechanism which allows the processes to communicate with each other and synchronize their actions. So because the processes are running parallelly, however we want them to be like to run sequentially or in some particular fashion, in some particular way. So IPC is a mechanism that provides or facilitates this operation. So IPC can be achieved by like a shared memory or sharing the memory part or passing a message. Like if I done with this, I'll inform the other task. Like that message passing is there. The synchronization can be of different types. So one type is like a task synchronization. Different tasks are running and we would to synchronize them. So the example I'm taking, I have some sensor that is tasked to write. So that sensor is reading the data and it is been written into some memory, some global variable. And there is another task which is reading that data and displaying that. So this task is completely dependent on this. So there should be a task synchronization. So first this task should execute and then only this task will can execute. So here there should be a task synchronization. These tasks need to be synchronized. Like first the chance to be given to the reading the sensor data and then only data can be displayed. So this is a task synchronization mechanism. The another one is the resource synchronization. Resource synchronization means like when multiple tasks are running and all of them are using the same resource. So that resource cannot be used by multiple ones at a time. So there should be a resource synchronization of one resource can be used only by one task. So in resource synchronization, let's say there are two tasks, like let's say in the case of mobile phone, one task is displaying the network strength and one task is displaying the battery status. So both of them are using a display. So what will happen ki task 1, the display will be allocated to task 1. Task 1 will complete the operation, then it will be taken out from the task 1 and it will be given to task 2. So here we are synchronizing the use of this particular resource, that is a display, and this type of synchronization is called as a resource synchronization. So these are the different IPC mechanism tools being used for the synchronization and communication. So signal, semaphore, mutex, mailbox, pipes, and message queues. And again, there are more, few more. So these basically are used for the maintaining the synchronization and having the communication between tasks. In the further topics, we'll see about details about these things. Thank you.